Yes.
You can start, madam. Sure.
So welcome back to all the participants after the break. Now I request Dr. H. Kumar Swami to introduce session speaker, Dr. M. Priyadharshini, to the audience.
Yes, thank you, ma'am. It gives me an immense pleasure to introduce today's speaker, Dr. M. Priyadharshini, Assistant Professor, Senior Grade 1, Vellore Institute of Technology, University, Andhra Pradesh. Madam has completed her BE in Computer Science and Engineering at Sri Ramakrishna Engineering College and completed her Masters of Business Administration at Bharati University. And again, she has completed her Masters again in Software Engineering at Sri Ramakrishna Engineering College, affiliated to Anna University. And she has completed her PhD in Availability in Service Computing at Anna University in the year 2016. Madam has 20 plus years of academic and industry experience, and she has published almost 16 international journals with 3 conference proceedings. And very important to be noted, she has published almost 21 international and Indian patents, and most of them are related to 3D printing, so which is a part of our mechanical engineering. And she has completed almost 11 certification courses, which includes NPTEL and other industry certified courses. She has handled many industrial projects. A few of them are like SIP processing, an application automating processing of SIT Limited, Chennai, user interface integrated software for Unigraphics model, Rismond Design Service, Coimbatore, website integration with content editor, Pyramid Technologies, Coimbatore, official website for Facket Technologies, Chennai. And she is actually basically a Oracle certified professional Java SE6 programmer. Our technical interest and areas of interest are like data science, machine learning and deep learning, service-oriented architecture, software engineering and testing, software project management, OOAD and UML, database management system, enterprise and web technologies, automation system, and technical skills are like C, C++, Java, Python, HTML, DHTML, JS, VB script, Struts, J2EE, Windows, Linux, and so many to name. We are very much happy to have you here, ma'am, and we are expecting more insight about the mechanical engineering applications by taking the applications with respect to machine learning and as well as deep learning process, how we can implement this with the mechanical application. Thank you, ma'am, and over to you.
Yeah, fine. So good morning, everyone. So as Sir told, my area is entirely computer science and engineering, but whereas the application what I'm working on is related to various fields. So we do data science projects, and anyway at the end of the day we come to machine learning and deep learning process. And since we had an interaction with 3D printing lab in in my previous college, right? So we had certain research work that was going on with respect to 3D printing. And so that is the reason how I entered into this particular field. Okay. So I use my programming knowledge, and then I give them the suggestions, and we do certain process which is related to additive manufacturing. And then and also I normally take sessions on computer aided designing. So all these together put me in this particular thing. So I have some knowledge on 3D diagrams, drawing, and I had, as Sir told, right, I have done a project which is an UI, user interface for ANSYS software. And so basically I was about to know a lot of things related to designing. And then after I started programming in various languages, I have knowledge in Java as well as in Python. So all these made me to enter into machine learning and deep learning. So today I have planned a session such a way that since all of you are mechanical engineers, so I need not tell you more on mechanical engineering, but even then I'll give you some basic things which you should know in order to cope up with what you can do with machine learning and artificial intelligence. I think this would help you to give a basic idea about what are the areas in which you can focus on. Since it is an FDP program, I need to give you some information on where in which research perspective you can do some work. And also I will say something about my patents, and so that with respect to patenting and in case of research also, how you could proceed with it. Okay, so I'll start my presentation as of now. Yeah. So to start up with, the session is related to additive manufacturing. So in order to enter into additive manufacturing, you should know what are all the other manufacturing techniques or technologies that we have. I think since you know better than me, right, what is subtractive and additive manufacturing. So what is the objective of moving into additive manufacturing? Okay, so whenever a raw material is given to you and you are about to create a component, so obviously subtractive manufacturing will help us to do certain process, and then we develop certain objects, right? Whereas in case of additive manufacturing, we construct the objects, right? And then by constructing the object, we are meant to reduce the wastage of the raw material that is provided to us, and the form of the material what we use is also different, right? The form of the input or the material, raw material what we use is also different, and there are a lot of constraints with them also. Okay, so anyway, we'll see everything in detail. So this is basically difference between additive and subtractive. So this slide is given so as to give you where all we can focus on, right? In which point your subtractive and your additive manufacturing differs, and then where you can enter or where you can introduce your programming or the conceptual knowledge of programming inside your manufacturing. Okay, so you can see that when we take additive manufacturing, right? So here we have we are adding the material layer by layer, right? So that is our concept, and then it is a 3D product, right? Normally it is considered as a 3D product. So here, in case of subtractive, we take a material and then we fabricate it as a 3D product. Okay. So here, when I take this first point, right, my focus will be on 3D drawings and diagrams. So and then layer, okay, all these terminologies just note down, and then when we come to the later stages, all these will be used for your from your research perspective. Okay, so layer is one of the important things that we have to know, and then it's a 3D product. So these two things is what we gather from the first point, and then next when we come complex shapes, right? So your very complex components, okay, could be designed and developed, because like we are going to do it in form of a 3D model, and then you're going to convert it into corresponding. So we as a user, we are just going to integrate it. We are not going to write a software in order to convert your 3D model into the particular object, right? So that is not the part of us. So anyway, but we can construct complex shapes, right? We don't have any restriction in constructing complex shapes in case of additive manufacturing. But when it is subtractive, you know that whatever you do, you have to do it with the machine, right? So basically, we do subtractive manufacturing using various techniques. CNC is one of the technique. So when I use CNC, as a programmer, I have to code everything in such a way that each and every design aspect has to be coded, right? It becomes essential for a programmer to code everything. Whereas in case of additive manufacturing, right, it is an automated process. So whenever I give just a diagram, that once it is coded, it's common for all type of objects. Whereas in case of subtractive manufacturing, for each object you have a different type of coding that has to be done, right? The process, the flow, right? The flow of each and everything that you do in your CNC machine, you have to code it in such a way, right? And then next is, even though we also have disadvantages with respect to additive manufacturing also, right? This could be suitable for materials having a low melting point, right? So here we need not in subtractive manufacturing, right? We need not so much worry about the melting point. We need to, but whereas it's not so much conservative. Okay, and next is the volumetric density, right, of the constructive material. right? Or what is the final object that we get? That also differs with respect to additive and subtractive, right? So in case of subtractive, no, when we remove all the what is it, like the unnecessary part from your raw material, normally you get wastage, more wastage, right? So, and then next point is about wastage, and then you know that since we are operating on machines, so we need to have a good lubricant. No, all together only gives you the better product, right? Here with respect to additive manufacturing, we have less what is it, like volume of these need of these lubricants, wear and tear, everything, right? So this is all general notion about additive and subtractive manufacturing. And then no, before we this slide, no, I don't know much about like all these hard and soft materials, but whatever we use for additive manufacturing, right? So you should have a good knowledge on what are all the types of metals we have, and you should also have, because like we have research work that is going on by merging lot of metals, right? So the raw material what we give and what we print. Okay, so when we come to the application, we'll speak about how metals are very much important when we do additive manufacturing process. So there is lot of scope in researches where you can design your own metals, and we also do organic metals. Okay, like, and sometimes we also use some raw materials which is made of organic products, and then that is even printed, which is natural, and it is used for various other purposes, right? So for example, we have filed a patent with the name of the patent is like you're going to have a material to design computers, and we have a hardware, to that hardware we design a fabricated material, and we 3D print it so that the heat that the layer could have withstand a high heat, right? Like that we try to design small combinations of substances also, right? That also we can do with 3D printers. And also the very important thing is the 3D printer should be able to take that particular material, and then it should be able to print it, right? So this important knowledge on what materials that we use, right? Raw materials that we use is very important. Okay, so this you should know, and you can also have a perspective of research in this area also, right? You can put combinations. Even though we have taken the gum that is taken from natural plants, and then we also print using that. Okay, so here with respect to materials, right? So here is a small discussion. You can see that what are all the process that you do in CNC, because since you are mechanical, I need not tell you all that. But anyway, so here you can see that what type of materials could be used in CNC machines, and in electrical discharge machining, what type of materials could be used, right? So that's what I told you, right? Even in some critical what is it, like areas, right? You can see that you do bioprinting, right? You do tablet printing, right? So you do organ printing, right? All of them comes under today's manufacturing, right? Like each and every non-living components that we develop, we also started developing living components, right? So human interacting components also, right? So with respect to that, this is with respect to subtractive manufacturing. So there are certain restrictions in materials also, right, which could be used, and some materials could not be used in your additive manufacturing. And there are certain aspects of research, for example, if I have a material with a particular strength, and if I am not able to use that in additive manufacturing, how to make it, how to strengthen it and make it possible in your additive manufacturing, that also could be a research perspective. Okay. So these are certain methods which we use in additive manufacturing. So I think you all know that. So we have stereolithography, and then selective laser sintering method, fusion depth modeling method. You also even have multi-jet modeling also, right? So material jetting, binder jetting. So all these are this are specifically for additive manufacturing. And then the raw materials what we use is in terms of not as always a solid, right? So it could be it could be in any particular state, it could be semi-solid, it could be sometimes we make it to be semi-solid and then we print it, right? So that are all the factors what we consider for research. Okay, so you can see these are all the materials. So for this only I told you, right, what are all the materials which is suitable for each type of process is limited. If you want to extend that, you can find a suitable material, you can design such a suitable material which is really needed for that particular technique, right? So these are all the other methods, right? It's not limited. You have lot of such new techniques emerging in your FDM, right? So you can use any of the method, and you can also find out, even you can think about, for which material, which type of methodology is better, right? And then you can test various samples, and then you can come out with a very good papers, research papers. Right, so not only in terms of electronic structures, mechanical structures, also in case of biological structures, right? So in case of biological structures, you need more number of factors that has to be considered. Okay, electronic and mechanical, just we need to consider only few factors like wear and tear, withstanding capacity of your heat, right? All that. But whereas in case of biological structure, you have certain more information to be handled. Right, so its compatibility is the main important thing that has to be taken care of, and then how do we create the structure of it also is very important, right? So in case of food materials, lot of things, lot of research is happening, whereas you can also think about this perspective. You can take a very small material and then you can try, or else you can take a combination of material and you can try, or you can take it from the perspective of your structures, whether it could be electronic or mechanical. You can take about a structure, you take a particular component, then try with all various methods, and you can do with which method is better and what is the, you know better than me, right, to take up the parameters, how to do testing, right? So there are a lot of tools available, right? So normally we do NDT in order to find out how better we have our that is the material composition being done using organic material. For that and all we do that, right? So this particularly additive manufacturing, as I told you, it's a 3D printing technology. So when I say just it's a 3D printing, the area, the core area in which you do your printing is very important, because we have 3 axes. Right, we have to maintain x-axis, y-axis, and z-axis in order to place or layer your object. Right. So, with respect to software, if you ask me what is a hectic task, converting my object into layers, how I'm converting that into layers is very important. But whereas with respect to you, when I ask you, your challenging point will be, when I deposit, right? When I deposit the layer, right? So, how much deformations are available? And what is it like, whether you are able to print without any small air gaps and all that, right? That's what you have to think about. So 2 things we have to think about. So how good we are going to do that, and how defective it could be, right? But only advantage is like we don't have geometric limitations, right? Because it's already drawn as a 3D diagram, right? We need not worry about how to machine it, how to tool it and all. We need not worry about it. That machine is going to just put it as a layers, right? So only we need to find or strengthen the object. How do we strengthen the object is very important. How do we create the object or create the layers without any deformation is very important, right? So this is the functional principle behind your modeling. Okay, first is your material development. So this is your model. This is the model that is done by any tool, and then the conversion of that into STL file, right? So that is what each and every layer should hold. What is the boundary of each and every layer? So based on this boundary, my head, right, my printer head has to move, right? So converting that into my movements of my printer head is very important. So that, because since it's 3D printing, we need not worry about that. Tool will take care of everything. So that's what we say it as an automated. So our main concern is about how do we better model it, and then how do we better print it, right? This STL file conversion is not a very big task, because like if you know how to do it, then I mean it's programmed in such a way, it's a available package, it will automatically create STL files. For it is a matter of nothing, right? So creation of thousands or lakhs of STL files is not a very big issue, right? Layers is not a very big issue. Right. So and then final product, what we get out of it, right? And then we have to when we do a testing, we could find lot of drawbacks. So why I emphasize on all this is our machine learning algorithm okay, or your deep learning algorithm is going to take each and every parameter that is going to be, okay, on your product, right? That is the 3D object what you have constructed, okay, and then it's all about how do we formulate our STL file, right? If there is any variation or optimization that could be done in order to create an STL file which could better suit our need, right? And then other variation is about how do we move our printer head, how to, so in case of, for example, if I'm trying to print one layer, if that we have certain deformation in the layer, if you find that deformation, then and there you can stop the process, you can again make some changes if possible, right? There are two type of defects you have. It could be reworked on, which could not be reworked, right? So then all these are depends on the TQM process that what we do, right? So this also should be integrated with your machine learning model, right? Machine learning model is used in various perspectives for your additive manufacturing, right? So here each and every line, see here, first is you're going to apply a thin layer powder material, right? So number one, when with respect to me, if you ask, okay, so there should not be any defect in the layer that is being applied in the building platform, right? If there is such what I say, like irregularities in that, then we may have a defect in our product, okay. And then next is how much laser beam is imposed on your product, that also holds, okay. If there is any deformation, if it could be, as I told you, right, two possibilities are there, whether we could make alteration during the production or printing process or after the printing process, right? That also differs, your time, your wastage of your materials, everything could be saved, right? So this laser beam, that also where it has to fix up, that also is controlled by our algorithms, right? And then the platform is moved, right? You know that, right? There are two ways in which you can do additive manufacturing. One is your platform will be stable and your printer head will be moving, and one printer head will be there and the platform will be moving, right? You have lot of variants. You can try small things and you can do some changes. Nowadays, you have good options in order to rework or remodel your 3D printing machines also. That's also what we are trying to do, right? We can also remodel the machine, the way in which it works, right? So the thing is, like, the precision is very important. With respect to additive manufacturing, the precision what we achieve is very important. Okay, so for that, how do we train our system is very important. So your achieving your precision is the main objective or optimization process that we do with machine learning. Okay. So when we take the advantages, what you have in additive manufacturing is freedom of design, because you can easily draw whatever you like, and then because it's automatically done by the machine and we need not worry about programming it into the operations, right? So complexity also, you can raise the complexity to whatever level, right? So elimination of tooling, as you know, right? And then lightweight designs could also be achieved, because that purely depends on the materials or metals what you choose, right? And then production step, we are going to do only one step for your production, that is printing process. Okay, whereas there are also disadvantages what we have with respect to additive manufacturing is slow build rates. You know that, right? In order to print one particular component, it takes very much time. That also could be optimized. Okay, that also could be optimized based on the the density of the material what we have, and then how do we print, and how in what temperature that we maintain. Lot of other factors also could be researched in order to reduce your build rates. And even though in one of our patents we have tried that, we try to have multiple printing heads, right? Multiple printing heads. And then we also have tried drone assisted printing, right? So like that, we can in order to reduce the build rate, right, you can do something, right? That could also be your research perspective, right? And production cost, how to reduce the production cost. As I told you, when you try to identify at earlier stages, while entirely you develop a product and find the deformities, instead of that, while doing itself, if you find the deformities, you can correct it. right? So and then application design is very important here, right? So that is what we have to consider about. And then application design is your model, machine learning model design. So once you do your model better, then your system could perform in a optimistic way, right? And then discontinuous production process. So for example, if in case any thing you want to stop it, you cannot, for example, if you are in your machine shop and one product has to come in order to do your next process, right? So in that case, since due to slower build rates, there will be a lag in the production process always, right? And then limited component size, right? You cannot have a printer which could print for the entire room size. That's what I told you. We have also trained drone assisted in order to increase the component size, right? And also there are options that you can separately develop and integrate it together as a component is also available. But in that case, you need to maintain, you need to find out whether your product is such a way that it could compatibility build together or assemble together, right? So all such factors are your research inputs, right? So all the disadvantages what you have could be considered as your research input, right? So commonly nowadays what they do is like this is the applications for which they use this additive manufacturing technique. So you can see that it's used in manufacturing of missiles and all that, and in academic institutions we do it for learning purpose, right? In medical, as I told you, right, all the human organs and your tablets and all that, right? So those are created, and then creation of your dental, right? So organs, right, as I told you, all comes under that, right? And then all your consumer products, right? Now toys and all, making toys and all, very minute toys, and then very minute materials and components, right? That is not easy, right? When compared to, if it's of very miniature size, it's easy for us to do it using 3D printers, right? And aerospace and all that, right? So it is varied. The application is very much varied, right? So if you see, most of it is used for all the industrial components and aerospace components. So now, what is the present condition and trend what we have in this particular field of additive manufacturing, right? So here you can see that using stereolithography, right, we create STL files, right, and it is your main 3D component is decomposed into various slices of 2D components, right? So you have to think about how to feed this each and every layer into your AM machine, right? And then this we use directly and indirectly, right, our materials in order to produce the prototypes, right? So there are, I think about rapid prototyping also, right? So rapid prototyping is a method which is used in order to develop only prototypes and not the original products. But whereas now in case of trial and error, they normally use rapid prototyping, and in case of usage, directly we started using. Initially, rapid prototyping was the only technique that they used, but whereas now we have additive manufacturing technique which is directly used and it could be consumed as well, right? There are certain techniques which use directly the raw materials, and there are certain things which indirectly uses the raw materials, do some process, pre-process, and then use it. Right, so this is the current thing what we do, and then future aspect. What you can think about is cost effective, right? So complex product, how do we do that cost effective? Because I told you that advantages is developing complex product, but in disadvantages we have told that it's not cost effective. So how to combine these two, right? And then that, right, material wastage you have to reduce. Obviously 3D printer will reduce it, but whereas the energy consumption is more, right? So how to make it balanced? So this is one aspect that you can think about, right? And then very important thing in your industry, in development industry, in software industry is whether we could reuse our designs. That's actually very important thing. In what we do is like we have methodologies called object-oriented designing and development in computers, where we have certain objects which is already available. Right, so we use that. With respect to computers, object is nothing but a piece of code. Okay, so what we do is like, is it possible for us to reuse it? Similarly, when you have a product and a product design, we can also think about just making some changes in the product design without having any additional expenses, whether we could construct it. Right, so however design should be for that. Okay. And then even you can even nowadays they're more concentrating on the biomedical field, right, where know how to fabricate your organs, right. So three important factors that need to be compared, I mean that you need to consider, as I already told you, right. It should be biocompatible, biodegradable and bioabsorbable. Right, so these three things, how to bring it. So if you say biocompatible, how do we bring in biocompatibility is again a very big research issue. Biodegradable, yes, of course, whether that could match with our process, additive manufacturing process, and how to make that to be incorporated in our manufacturing process. All that is a very, it's not just you can say in terminologies, but when you bring into existence, because it's all organs, about organs, right? So they should function without any wear and tear, number one, and then it should be more compatible to the human body, right? So this and all could be your aspects which you can think about, right? So all these what we have seen, right? So then we find out what is the gap that could be solved using our additive manufacturing technique. So where all you can focus on. Okay, so one, we can focus on material development and evaluation, number one, as I told you, right. Next is design methodologies. How do we design? Next is controlling, for example, once one layer is completed, I take an image of the layer, find the deformities again, before I print the next layer, how to, so I cannot even each and every time stop. I may have, that, right, it is not like 10 or 20 layers will come, right. In one product it will be thousands and lakhs of layers it will be, right. So I have to take each and every layer and finally form and find the final product, make some changes, visualize it, and then I have to bring that into my controlling process, right. So and then next is characterization and certification. So all these areas we'll speak about in detail. So these are all the challenges, general challenges other than technical things. Right, what your system is capable of financially, how you can achieve that, and with respect to design and with respect to IT integration, all these are challenges, right, which you need to concentrate on. If you see, now we are into the phase of identifying what is exactly needed. All right. So number one, with respect to material, all right. So you can see that you can do an intensive research of the material. As I told you, we have tried with more organic materials. So it's not always necessary.
See, all the three. All the three.
Okay. So intensive materials is it's not only about organic. Okay. Also the metals what we have, that, right? Composition of metals can do wonders. Right. So that too, with respect to additive manufacturing, we have to do it without, without doubt that you can try out a lot of things, in order to reduce the burden of the manufacturing process. Right. So there is a survey that around it takes around 10 years to develop a new alloy. Right. So and then you can see that already available materials, you can make some composition changes and you can bring them into a position that it could be used for additive manufacturing. Some changes in your materials also could be done, or you can develop an entirely new material which is specifically for the purpose. Right, very simple, right? We go in for construction, constructing each and every house or office, right? So each one have its own need. Right, very simple. Another example is like when we try to develop fiberglass insulation materials. The fiberglass insulation materials are designed and developed in such a way that it's for resistance, right? I think you know that. So when you use it in manufacturing of the vehicles, automobiles, and all, your fiberglass insulation materials have to withstand a high temperature at certain places, right? So in that cases and all, you have to fabricate your material in such a way that that particular material, it could withstand that particular heat. So how to fabricate that, right? How to so similar to that, the fabrication process, what we do, yes, that could also be brought in. Similar to that process, whenever we try to insert or whenever we try to include a material inside your printer, right, you can do such intensive changes in your material, right? So similar to that. Okay, and next is when you think about design, right? So design is about entirely tools, right? How we design it and how much your tool designs it in such a way that you have various projections and metrics, you know that, right? And also various formats you have, and relationship between one layer and another layer. There is a thing called, for example, if you have one video, you know that it's combination of many images, right? Everybody know that, right? So similarly, when I am going to layer my system, right? So if 10 layers is there and all the 10 layers is going to be one particular solid layer, so my designing tool should be in such a way that it should create the STLs, right? So and then the shapes and the the angles in which you design your model is also very important, right? Because it's not only with respect to 2D, it's also 3D, right? So anyway, we have lot of such tools that we have which could do a better 3D designs today, right? And then how it is being converted into a format which is needed for conversion of STL files. That is very important. Okay. So that we have certain packages using Java which could directly convert that into STL file, and in that also we can include some optimizations, right? That could be done only if you know the designing the working of your designing tool, then you can do it easily. That's why I concentrate on this part also. For example, I do a 3D model and then that is to be given as input your manufacturing machine. So in that case, what we do is we create STL files, right? We go and do some modifications in the STL files also sometimes. So using machine learning, you can do it on the fly also. On the fly is in the sense during your printing also we can do that, right? So all is a matter of how soon we identify it, how fast is your machine learning model, right? So and then if you see that, you can also have some research perspective with respect to modeling, sensing, when you sense your data. So even we have, I told you that we have technologies which is related to beams and crystal structures, right? So we have lot of factors which could be sensed and then it could be intimated to your system, the controlling process, and you can do some modifications in that, right? Or else, if there is a major deformation, you can stop it, right? So that's what I told you. It's very difficult to predict the microstructures and fatigue properties, right? So that could be done better if you have a model which could do this process better, right? Sensing process and then controlling process. So sensing is very important with respect to microstructures, right? So and then that's what I told you. You should be very fast in measuring the parameters. So as I told you, machine learning model parameters is only important. The value what you take is important. How many values you take is also very important, right? So that should be in seconds. Not in seconds, right? Even it's a subpart of seconds, right? You should be able to track the data, right? So if you go in for real-time production system, if it's just an trial and error system, it's okay. But whereas we are going to do that in a real production environment, so then you should be more worried about this rate in which you take the input and rate in which your model works and all that. Right. So that's what I told you. Rapid prototyping is entirely different, right? Even though we use that technology to do it, but whereas the thing is, when compared to rapid prototyping, it's just for the purpose of prototyping. It's just like a trial and error. So the recommendations, what you can try, okay? Number one is development of new materials, formation and mixing of the materials. As I told you, you can use organic and you can change the parameters, the properties of your metals, and you can try it. right? And then with respect to design, you can introduce multiple functional methods and tools. As I told you, if I have a very big component, even I can try about thinking, I can componentize it, and 2 or 3 heads could be used for printing the component at the same point of time, right? And then with respect to developing your machine learning models, and then your manufacturing model, right? So your parameters, what we do, right? That also could be done, very simple, to say very simple. There is one research being conducted, just to what is it like find the withstanding temperature of one particular metal. They have done the entire PhD on that. Only the work that he has done is extensive research on the temperature, till which temperature this particular material can withstand, because that one point holds lot of allied applications, right? So that purely depends on material what you choose. If it's a very critical material that is used very critical purposes in any one of the industry, any one of you can take that particular material and you can try it, right? So which is the want of the day, that and all you can try it, right? And as I told you, right, prediction is a very important word. Note down, and we'll see that in the machine learning models. Okay, what is prediction, right? So fast response sensors is what we need, right? And then real-time sensing, and once you sense it, what the other process should happen. How do we bring that into our system is very important. Okay, that's the closed loop control, right? I need not tell you what is open loop, closed loop, all that we know, right? Feedback system. So that how it reacts to that. Sensing is a different thing, and once it senses, how soon and how well it interacts and converts your changes your printer head, changes your angle of printer head, right? All that holds, right? Change the the intensity of the beam that is passed in order to do manufacturing. All that is the closed loop control, right? Finally, our objective also could be dragged in terms of production costs, manufacturing times, right? And then in order to reduce our wastage. So these are all the recommendations that we could do in the area of additive manufacturing, and we can do a lot of research, and a lot of research are also going on in this area. Okay, so now we enter into how your machine learning, your deep learning is going to integrate with your additive manufacturing. So before that, I'll give you some glimpses on what is machine learning and what is deep learning. As your mechanical engineer, I don't know whether you could had gained knowledge on this, but anyway, whichever is very important aspects, I'll tell you. Okay, and then we'll move on into some applications. Okay, so there may be a lot of confusions regarding what is AI, what is ML, what is deep learning, and all that, right? That normally we too have, right? When we started exploring machine learning and deep learning, we too have that particular. But whereas being mechanical engineers, you should know what it is exactly in order to use that in your applications. Okay. So number one is artificial intelligence is not programming something, right? So from the environment we gather some information, right, and then react to that. Okay, so that is what is about artificial intelligence. And next is machine learning. Okay, machine learning is, we have a machine, computer is a machine. That machine is going to do process for us. If I write a program and ask the machine to do or execute the program, it will execute the same way. Very good example is playing a chess game. Okay, so if I want to play a chess game, right, if I make a move, right, I cannot code all the moves by my defender, right? That is not possible. So based on the move what I have done, the defender has to do the changes in the system. So these are all the applications where you could use machine learning. And machine learning methods, right, the important concept is learning process. How do we make the machine to learn? How do we make the algorithm to learn? So algorithm itself restructures. Okay, so algorithm is not predefined. It is an algorithm which restructures, right, and predicts something and response to the user. That is very important, right? Whereas deep learning works, machine learning is we are making our computer to take the data which is previously available, take some decisions based on the data which is previously available. Okay, that is what machine learning does, right? Whereas what deep learning does is, the other name for deep learning is neural networks. Okay, so what deep learning does is, it works as if how our neural system works, right? So think about how our neural systems work. So for example, think about a doctor. Okay, think about a doctor who is practicing, and think about a doctor who has done his service for around 30 or 40 years. Okay, so similarly, think about a teacher who is going to teach day one, and the teacher who has 16, 17 years of experience. Right, so what is the difference between both of them? Okay, that is your neural networks. That is what we are trying to bring into computers. Okay, what it exactly does is, when I'm a new doctor. Okay, think first patient is coming to me. Okay, so I would have studied something, and then based on whatever I have studied and whatever I know, I ask him set of questions. He may give me the set of parameters. Based on the parameters he gives that, I'll find out, okay, this may be the symptom of this disease, diagnosis. Okay, so and then I'll give him the medicine. So this is a doctor who is first day doctor. Okay, so next doctor who is there for many years. Now what he'll think about? So he would have dealt with, he has seen more such data, right? So and he would have taken such data, and for a particular person he would have given a medicine, and that medicine was wrong. Okay, so you know that, right? There is a process called rule out, right? What they do is, like when you go for the first day, he'll give you certain medicine and try. Okay, go and try for 5 days and come, he'll tell. After 5 days, when you go back, he'll identify what is the actions that have happened, and then based on that he'll change the medicine and give you. Okay, if his prediction was correct, then you will get recovered the first rollout itself. Right? Similar to that, when the prediction will be correct, if the doctor is experienced and he has seen more number of cases, it means that more number of data is available with him. His neurons, his neurons in the brain will try to find out the possibilities. What is the possibility? Okay, this may be the reason. Okay, this is not the reason. No, the process, what he does is done by the algorithm. Okay, we are creating machine learning, deep learning algorithms, which is going to work as if a neuron. Right? I think you would have seen the film, Robo, right? Endren, what we have in Tamil. So in that, he'll program everything, with a lot of data. Right? If lot of data is programmed, so if the machine gets an input, it can use the knowledge which is gained. That is what is learning process. The knowledge which is gained by the data and react accordingly. Okay, so machine learning does with one layer. It will take the input, it will find, okay, this and all matches, then give the output as such. But deep learning will think like humans, 2 or 3 layers, 4 layers, 5 layers. It will think step by step, and then it will do the process based on the input. Okay, based on the combinations. That is what is deep learning. If you know this, then it's nothing. Okay, what you're going to know, the application and all, you'll do it in an easy way, and then you need not worry about what algorithm you use. Right? Only we should know how that algorithm works. Okay, so we are using machine learning and deep learning, and it is specifically used for data science. Okay, so data science is extracting knowledge from the data what we have using any of these algorithms. Okay, so all the forthcoming slides, it will be easy for you. As I told you, right, machine learning is making your computers, right, to optimize their performance using the example data or past data what we have. So if you have more data, the prediction will be accurate. If you have less data, the prediction may go wrong. This is the logic behind machine learning. So that's why normally we say take a data set which is very large. Right? If my data set is very large, then my prediction will be correct. Okay, so machine learning is used for speech recognition, computer vision, medical diagnosis and all. and then robot controlling a machine, how a machine works. So this is where no automation of your system. So I need not tell you, right? Your entire machine shop could be automated, right? Lot of things are happening. No, we need not go. So the way in which the flow happens, no, it is already pre-programmed, right? If something happens, no, the machine learning will see to that. If something happens bad, also it will be able to control by itself, right? For that we introduce deep learning, right? So this is what is about machine learning. These are techniques what we have in machine learning. Okay, but you should know when to use which technique. Okay, so machine learning has three different methodologies. One is supervised learning. Okay, supervised learning is you have a data. Okay, and you know what all the proper. Very simple. If I want to say any information on supervised learning, no, there is somebody near us to tell. Okay, if this is the case, this will be the output. This is the case, this will be the output. Right. So classification. So a very example, you know, with respect to additive manufacturing, I'll tell you. I take an image, okay. I take an image and check the layer, no, which is being designed. So if there is no deformation, okay, so I say that to be a better image. If not, so we give the accuracy, how much better it is, right? That is classification. So for example, I give an image of a mammogram image. So it is, by seeing the mammogram image, it will say whether it is malignant or benign, right? Whether yes or no. But this belongs to this category or this belongs to this category. If you are able to classify it, right? But for classification, we have inputs with us. That is called classification, right? Whereas I don't have inputs with me. From the data, I take everything together. And then I decide upon this may be this. Okay, it is unsupervised. By clustering all the data, I come to a conclusion. Okay, so if I have 1000 data, I try to see how the data is available, and then from the data I find out, okay, whether it is deformed or not. That is unsupervised. So supervised has a set of predefined inputs, training set, and then model is designed, so you can validate and say yes or no. Okay, that is called classification. Classify into this or classify into this, right? Whereas unsupervised learning, you know, our algorithm should try to find out similarities, dissimilarities, take whichever one is similar, and then from that we come to a conclusion. Okay, to be very simple, I'll tell you an example. I give you an image, okay. I give you an image and then I ask you to find which one is mobile and which one is laptop. In the image I have mobile and laptop, and then I say if it is of rectangle shape and if it has all these properties, I have a list of properties. If it is there, that will be a mobile. If this is there, it will be a laptop. So based on that I can classify. Okay, but unsupervised learning, you know, what it does, I don't specify how it should be. The value, you know, I will not specify. So what it will do is, like, it will take a laptop, it will take the entire image, try to relate all things. Okay, mostly laptop and mobile, no, both will be of same shape. So then what is the other thing, no, which is in common? Like that I find the commonalities and try to identify what it is. Right, whereas the clear input, the data set, no, with the classify, the labels is not given. Okay, so that is one method of machine learning. So normally very small, very small cases, and the cases in which we are very clear with what is what, no, we use classification, supervised learning process. Most of the cases we use unsupervised learning process. Right, and also for real-time scenario we use reinforcement learning. So real-time scenario in the sense, right, we are playing a game, right, based on the movements that we make. Okay, so the algorithm will get the input and automatically it will change by itself. So I'm reinforcing it. Right, to be very simple, no, for example, you have your mobile in which you have Google Maps, right? So whenever you change the route, automatically the Google Map maps the route, right? So when you are about to move to a particular place, no, by input that is there in the previous iteration, based on that it will automatically adjust. Okay, so this is about machine learning. So these are all the methods of machine learning. Okay, so we have supervised, means we have regression, decision tree, random forest, and classification. Unsupervised, we have clustering and association analysis and Markovian models. Okay, so this particular data, what you have, no, that also decides which method to use, whether it is categorical data or whether it is continuous data. So, for example, no, I may get data from the sensor continuously, right? Or else, no, a data which is based on some category, I get my data, and based on that I do some analysis whether this is related to that. So that also your algorithm differs, right? So these are all applications where we use, right? Classification is used for fraud detection, email spam, right? So here I told you, know, whether an image or a layer which is printed, okay, is a layer which could be accepted or rejected, right? So like that we have lot of such applications for each and every machine learning algorithms. Okay, so this is what I told you, labeled data, because labeled data is already, I know that this particular data comes under which category. Okay, so that two processes are there, training process is there, prediction process is there. With the data I train it and predict it. Okay, so if your training data for training is more, your prediction will be accurate. So I have an algorithm, the algorithm is given with the data, the algorithm is trained, I get a learned model. Okay, so this learned model is the one which is going to be executed when I give an input. This will not get executed, only this will get executed. Okay, so the result of that will be prediction, whether this belongs to this category, this label, that label or not. Right? So a very simple example is, as I told you, emails. When you send an email, if you notice that in your subject, if you put words or hyphens and most number of special characters, that will not be forwarded to the user. It will be considered as a spam. Right? So all that is due to the prediction that happens in your in your data, and then which is traced by your algorithm, machine learning algorithm. Okay, so now a small variation in your machine learning and your deep learning is this feature extraction. Okay, and then what are all the features? That is, for example, I get an image. From the image, I take whether it's a human image, whether it is an animal. If it is a human image, eyes, nose, all that I take separately. So similarly, whatever the data you have, each will have a feature. For example, if I take a mammogram image, right? So which part of the image has to be taken and which has to be compared, right? So I take a video. Okay, I never always consider the entire video. For a very good example is a cricket match, right? When you see the cricket match, when third umpire is being raised with the request, no? In that case, you know that, right? Which part you have to extract and which part you have to notice, right? All that, there are lots of applications that we have, right? So here you can see that in case of deep learning, right? Everything is done by the algorithm itself. Feature extraction is also done because human can do everything, right? So here human does feature extraction and then ML algorithm is used, whereas here the algorithm itself will detect things. Okay, so I think we'll move on fast so that now we can come to applications and then I give you a few examples. Okay, so you can see that here some human is involved and then only your algorithm is involved, whereas in deep learning, the entire algorithm is done by the deep learning itself. Okay. Very important thing is input layer is the layer through which you give certain input. So for example, if you want to diagnose this particular material is suitable for this process or not. Okay, so then I give various parameters that is tested. Right, so all the parameters is given as the input, and then I try to find out with my past experience whether this material is suitable for this process or not, whether I can use this as a raw material for 3D printer or not. Right, for that I can use neural networks. Right, and then next, this is one example I have given. So and then some sensor data comes in. So when this particular sensor has this data, right, whether I can accept or whether I can proceed with printing, whether I should stop printing, whether I should change the X position, Y position, Z position of my printer, whether I should elevate, that is move or lower my printer head. Right, so all that, each and everything that we do in the process, right, could be decided automatically by your neural networks. Okay, so don't worry about that, because like these layers are, we need not going to write, we are not going to write a code for the layers. So all packages are already available. What we do is like we use the packages and then we decide which function to use. Okay, so this is an example for neural networks. This is neural network types. Okay, there are two types. One is feed forward and is feedback methods. That is, you just keep on taking decisions from the past data. That is feed forward networks. But whereas feedback networks, there will be some, so there is a method called LSTM, right? Short term memory. Like what we do is like, it will take the input, it will store certain details of the previous things that has happened, no? Previous layer. For example, I have 10 layers. First layer data and second layer data, it will keep it in the memory and then analyze the third layer data. Okay, so that is actually recurrent networks, recurrent neural networks. So this is a sample for ANN, okay, artificial neural networks. Here you can see, various parameters will be fed in, and then we decide based on the data that we have whether this particular parameter is important. So how much this parameter is important to our decision. Okay, very simple. Nowadays, it's pandemic, right? Whether to have a class online or offline. Okay, if that is the question, you have to take n number of parameters. Yes. So next is with respect to our manufacturing process. I have 10 metals. Okay, 10 metals with 10 different parameters. All of them are fed in. Okay. So already we have a history of these metals are used for this purpose. Every data we have. So we have already done, how many printing we have done. So automatically when I give the details of that is multi-layered. Okay, we have a lot of variance in the neural networks. Single layer, so this is what you have, right? Single layer, multi-layer perceptrons are there. And then next is single variate and multivariate. Whether we are going to consider only one variable or n number of variables, that also holds. Right? Simple thing you have to think is how a human will think. If I have n possibilities, I'll put combinations of everything and decide whether to do that or not. Similarly, your machine, okay, I give functions, I ask it to use functions like there is a function called ReLU, okay, there is a function called sigmoid, there is a function called tan. So each of the function will make some variations in the data. Right, I use all these functions and then I try to find out whether this particular prediction what I do is correct or not, based on the data that is available. Okay, so it's like entirely how human works. So here this convolution neural network has one advantage. What it does is it tries to rule out the unnecessary combinations. Okay, very simple for diagnosis. If I want to diagnose a person, okay, whether he has COVID or not, I take my lungs function test, I take a chest x-ray, right, and then along with that I take whether he has fever, right. So these three parameters, if any one of the parameters is not there, what we diagnose is different. If all the three parameters are there, so each and everything, when put in combinations, have a different perspective. So features when extracted. So for example, I have combinations of metals. So one metal, another metal, when I combine them, it will be a different composition. If I take three metals together, then the strength and everything will be different. Right? So this convolution neural networks will help you in identifying the, the discrepancies that arise in the combinations. That is what is convolution. Right? So for that we need pool of data and then we do the process. Okay, so CNN is used for that purpose, and then RNN is, as I told you, right, recurrently if I have to keep some data in the mind and then based on that I have to work, right, so automatically RNN will be used. Okay, so now we'll see the applications. You can see that, right, so where all you can do is you can use to find the deformations. Right, so we develop a product and then we take this specimen of the product. Right, so I think you know what is FEM. I need not tell you. So we create FEM models, right, finite element models. That will give you an idea of what is the property and how the element, right, is formulated. Right. So from that what we do is we take such more number of products and then we take the FEA, we feed in the data, right. So automatically lot of such data will be there already available. Each second I track the data and put it inside my system, right? And then whenever I am given with a new product, new specimen, automatically based on the already available data, right? So it will find out whether the deformation is not there, because already I would have done. So if this is the case, the deformation is there. If it is the case, deformation is not there. If these three combinations are there, then we can say that it is deformation, right? So for this, no, we have a neural network called LSTM, as I told you, right, with some memory, that is RNN network, right? So previous cases, no, before movement of one particular slide, no, in that FEM. So what was previous and what is next? So if that and this happens, both together happens, then I can consider this as a deformation. If both are not happening, only one has happened, I never consider that as a deformation. Right, so for that we use, and one more example is monitoring. Okay, monitoring. For this we use an CNN model. So sensor CNN model, you can see that. So here you have certain elements being developed. You can see here. Okay, so based on the signals that is emitted, right, by sensors used to track the signal. So for example, we have sensors like sensors which captures the velocity and sound, right, based on which, no, we try to take some decisions, right? Similarly, also you can know that even sound is used in order to identify the deformation process, right? So what sound that particular materials in that particular layer makes, no, reflects, based on that I decide whether it is deformed or not. That is also available, right? So the printed layer, no, if it is properly printed, no, you will have a wave, acoustic wave based on that. See here. So what we do is, like, if we take in series of acoustic waves, it's a continuous data, not categorical data. Okay, so I take a continuous data, and based on the continuous data, right, I can decide upon the porosity of my material. So I decide based on the porosity level, no, I decide whether it is deformed or not, whether the layer printed is exact or not. Right. So this SLM method uses mostly this particular technique, SCNN, in order to do that. Identifying whether the quality of the printed layer is good or not, right? So again, no, one more thing is like images. No, based on the images, no, one is acoustics. As I told you, with the respect to sensors, we take the data. Similarly, now what we do is with respect to the images that is applied. Take flashes of images. Whenever it is printed, it takes many images, and that particular images, okay, is taken, and you can see that. So those image processing is done, right? We filter it. We find which area is very important, which particular. So for example, minute designs and all, we have to do this process. Okay, whether this particular curve or angle, whatever it is, or else, if you design some hydraulic systems. Right. So hydraulic systems, you know that even if you have a small change in the size or small minute change in your angular, the way in which your hydraulic system works will be different. Right. So I think you also have certain tool for doing analysis on fluid dynamics. That is a different thing, right? So here you can also, even the fluid dynamics data could also be fed into an machine learning algorithm, and from that also you can find whether there is a defect in the component that is being designed. Alright, so all these things, the data matters. What type of data it is, whether it's video, whether it is an image, whether it is just data that is taken by the sensor. Right, so all these data could be used in order to come up with a prediction. Okay, whether something is going to happen, or what will be the strength, even that you could predict. Okay, when you have all your layers being constructed, what will be the strength? Even your prediction models could be designed for that purpose. Okay, I think I have given you some information on how neural networks is used for additive manufacturing. So, and then finally we come to the last slide. Okay, so here you can see that the current area of focus, what we do is detecting the defects, as I told you, right, defect detection, and real-time control of your entire manufacturing system. and then predictive maintenance. No? What may happen and how we could avoid the errors happening, and then you can better do the maintenance process. Okay, so this is your current areas of focus. So and then near future, no, what they are currently focusing on is right prefabrication printability checks. That for example, no, if I am going to use this particular method and if I print, right, it's like prototype, right? So before fabricating, we make a pre-check. Okay, whether this is fine, then you introduce. Whether this is fine, you introduce it. So you can include all that thing. If it is not, we need not include, right? So that also is being done before the fabrication process, not during the fabrication process, and then reducing the complexity, right? So as I told you, right, if your product size is small, and then if you have some intrinsic design, so the behavior of the printers, right, and then small components of the printers could be introduced, right? So for example, no, instead of printing one particular material in a particular nozzle, you can reduce the size of the nozzle, and you can have two nozzles. During one scenario, one nozzle works, and the other scenario, another nozzle works. Right? If that could optimize the way in which you do that particular or do that particular layering, then that also could be done. Right? You can even customize the entire process. Automation. You can automate the entire process. Right? Even then, no, if there is some change in the angle in which you that is your XY Z axis also, you can automatically change the printer head and make it correct during the process of printing. Right. So and then next part is about reducing the talent threshold for manufacturing industries. We know that there are a lot of limitations that you have in your manufacturing industries, so which could be automated by this machine learning algorithms, right? That also could be done. And next is about cyber security, right? So nowadays, whatever we do, even you can say a good example is biometric. Right, so the detection of things, even I can create an iris or whatever it is using additive manufacturing technique, and then I can use it for the purpose of some security breaches. That is also possible. Right, so how to avoid that, and what you can build in order to, what you can construct in order to reduce that. Right, so how it could be integrated to your entire system, automated systems. Right, so all these are certain aspects in which you can think about. Okay, so we have come to the end of the session. If you have any queries, you can ask me. If you have any queries regarding machine learning, because you are new to machine learning, you will not have it in additive manufacturing, I hope. But you may have it in machine learning. If you have any doubts, so that you can proceed with your further work, you can ask me. Ma'am, I have a doubt in which neural networks and about machine learning, or about when to use, where to use, and all. If you have any doubts, probably you would have studied many papers, in which you would have seen this technique is used for this purpose, and these changes are done in the neural networks. You can ask some questions on that also. Do you want to see a small implementation of, I'll show you a code of it, okay? Shall I?
Yes, madam, yes.
Ma'am, yes, I'll show a small CNN model so that you will be comfortable with. I'll show you so that, you can see how easy it is, because only the matter of if you understand the concept, coding is nothing, okay? So I'll browse through from start. Okay. Is it okay? Were you able to see the slide? See the letters? Yes.
Not yet, madam.
Okay, I think I have to. Very good. Very good. I have to share it once. I should share this. Fine. Now you are able to see.
Yes, ma'am. Yes.
Yeah. See here. This is a sample code of CNN. Okay. You can see here. These are all the packages which is available. Okay, so for example, if you want to develop a machine learning algorithm, right? These are all the preliminary steps. What we do is like we'll check what are all the packages. Okay, that is this is done using Python. This is done using Python. So Python has more number of machine learning packages which is already available. So Keras is one among them. Okay, so which has the process to which has the packages to create the neural networks. Okay, so what I do is I'll import whichever is needed. Okay, whichever is needed. So for doing convolution, I need CONV 2D. For pooling layer, I need max pooling. Okay, and then activation functions, I need activation package. Okay, so these are all the packages that is available. So the thing is, where you have to start is, first you have to understand the concept of that particular machine learning algorithm. Number two, you should clearly have an understanding of the data set what you have. Then when you give the data set as the input, now how you have to construct the neural networks, this model is important. So now these are all the packages. First I have to import whichever is needed. Now see here, I am building a neural network. Okay, I am building a neural network, and then I decide, okay, I should do that sequentially, one after other, because CNN means first process will go, then second process will go, and third process will go. Okay, so TensorFlow is a mechanism using which you can do parallel processing of multiple data. Okay, so now what I do is, first I take whatever the images I have. This is done for an image for classification. Okay, so image is classified into one particular category and another other particular category. Okay, so you can see that first I have to load the data format. So which data format? Next, I am adding the, see here, can you see that? I am adding the CNN network. Okay, so this and all, you should know what these parameters and all, what is the filter that you use. I told you that, right? The images, it will be filtered, and whatever data I want it separately, I can filter it and take it from that particular image. Okay, then I add an activation function. I told you, right? Activation function will decide upon how important is this particular layer for our algorithm. Okay, so this will activate. So this is like you have summations, you have average, right? Like that, activation is a function. Okay, so this is a function called, there is a function called ReLU, rectified linear unit. So, and then I want to normalize my data before I pass it into my next level. Okay, I remove all irregularities and all process I do normally, right? And then I pool my data. What is the size of the pool? Right, normally images are represented in form of a matrix. Okay, that's why you can see many places all matrix 3 by 3, 2 by 2 is given, right? And then there is a process called overfitting. Okay, overfitting is some data may be abnormal, right? Some data may be not needed for our decision making. Okay, that and all is, it could be underfitting or it could be overfitting. I can remove all of them. That is called dropout. Okay. So, see, can you see that? You can see each and every, this is first layer. Okay, this is first layer of CNN. Next, I am moving to next layer. Like this, I create multiple layers. Can you see that? Second layer, third layer. I can keep on creating the layers. And then I need to connect a fully connected layer. Okay, so after that, what I do is like I can do my.
So how this plays an important?
Yes. So what we do is like we can flatten our data. So all irregularities will be removed, right? Whatever the process, each and everything you have to learn what it is. If you learn this, it is a model. No, now it's a model. Inside this model, if you give an image, right? Inside this model, if you give an image, a set of images, can you see that? Set of images will be given as input, set of labels will be given as input. For example, if I give an image and say this is dog, this is animal, this is human, like that, if I have to give the images and then I have to give the labels. So similarly, you can also give data such as that, whether your layer is correct, deformed to which percentage, everything you can feed in. So you can give image, so this image is deformed 20%. This image is deformed 10%. If you load all the data inside, whenever you give an image, automatically the deformation percentage will be known to you. And then you can say that whether this particular layer could be accepted or rejected. Okay, so this first part is construction of model. Second part is you are loading the input. You can see that you can load the input. You are reading the image. You are making the image size equivalent to that of our network, no, whichever our network wants, CNN wants, and then I can print whether this particular image is, I mean, after filtering and all, you can see the image. For that, just we have printed it, and then you can see that we are testing training set is created. Okay, so all these are the preliminary process. No, after creation of the model, I send my data and test it. Yes, it's working. Right, so this is a sample for construction of your model. So if you see, all the each and every step will have the output that is printed in form of graphs and images. Okay, for this we also have a method called OpenCV in order to process images alone. If you want images deformation and all that, you can just do your you can use your OpenCV. And then tensors are very important thing that you should know in order to do prediction process, because if parallel data set is very high, normally we use tensors. Okay, tensor is a unit of processing. So I can have n number of tensors created, and then I can do my process. So I think I have given some information on how it will look like, right? So within this point of time, I can do only this. Anything else? Sir, finish, sir. Over.